All right, guys, welcome to another channel episode. This is a channel where you don't need to be a CEO in order to have some impact on the world. And this episode will be a prime example of how you can have some impact by just following your side projects, and maybe potentially can lead to something you did not expect before. And in this episode, I'm going to talk about the findings of a grit study, and I performed some EDA on it, and I found some things that the original researchers might have not been able to find. And so therefore, I might have some impact on the world. We'll see about that. But if you guys want to follow along, there's a link below, and I'm just going to get started going over the project, and let me know what you guys think. All right, so let's get started. Here's my GitHub. All right, so let's actually make this white. All right, so let's go over the basics. First, I'm a data scientist, used to be an economist, and I'm based in Miami. And if you guys want to contact me, please contact me through LinkedIn, through YouTube, for whatever. Here's my Twitter and LinkedIn. And so this project's all about grit, but we should first define grit because not everyone might know what grit is. So grit from Wikipedia is a positive non-cognitive trait based on an individual's perseverance of effort combined with the passion for a particular long-term goal or end state. The particular part that I want to focus on here is that it's a non-cognitive trait, which is important for later on. So grit was defined by Angela Duckworth, the creator of this study, perseverance and passion for a long-term goal. So that's a more simplified version of the Wikipedia from above. And yeah, it's just how gritty you are is basically how long you continue through a goal, even when things get difficult, even when the timeline is longer than you thought. And some findings that Angela Duckworth found were that grit is a better predictor of success than individual talent. Particularly, she looked at GPA among Ivy League undergrads, dropout rate in West Point U.S. Military Academy, and in the National Spelling Bee. So this is a very compelling study. She actually has a book and TED Talk on the topic, and I added that right there. I suggest everyone go look at that right now before continuing. So let's move on. So the scales. So each psychology study is called a scale because it's, scaled in a way. It's scored in a way. It's called scales. And this data set had two of them. The first one was actually about a personality test from the International Personality Item Pool. It's a very popular personality test that multiple people have probably taken, and it's something that, at least in the US, it pops up all the time in schools and in high school and college. So it's a very popular study, but it also had the grit study, which was new, and Angela Duckworth actually invented herself. Now, it also had a set of biographical questions that were, useful for me in order to find out more about the background of each person in the study. It was conducted through an online personality test in 2014, and I had a little bit more about that at the end of this project about, the downsides of this kind of method of study. The data set had around 4,270 observations with 98 columns, and it was a mix of categorical and numerical values. So yeah, as I mentioned before, the personality test that was included before the grit test was actually a very popular one from the IPIP, and I went to their website to learn more about it. And it grades people on kind of 5 personality types, or at least these traits, you would call them. The 5 traits are actually extroversion, neuroticism, agreeableness, conscientiousness, and openness. And I added a definition. I won't go into each one right now, but mostly they're exactly what you think they would be, except for neuroticism, which is basically just the trait of someone being emotional. So try to remember that. That's what it means. And I found out through the website that it's graded in a special way. So I had to write a small function in order to grade in order to score the scales. And so I was able to do that easily. And then I managed to graph the different traits. So here's the graph of the different traits. As I mentioned in the text, openness and agreeableness are left skewed, while extroversion, conscientiousness, and neuroticism are actually kind of normal. They won't pass any normal tests because the tails are cut off, specifically around like 20. You can see that each one is cut off. -20, that's just because that's the minimum and maximum scores you can get. But what's important to note here is that openness and agreeableness are left skewed. And that's kind of what I wanted to learn from graphing these. So yeah, just more on that IPIP test. It was graded on a 5-point scale. The questions had a 5-point scale to basically answer on, and number 1 was disagree, 2 was moderately disagree, 3 was neutral, 4 was moderately agree, and 5 was agree. And they were all presented on one page, 50 questions, and I like added some examples right here. Number 1 is I am the life of the party. Number 2, I am relaxed most of the time. 3, I feel little concern for others. And 4, I am full of ideas. These are just random ones I selected from the 50 questions. And so you can get an idea of the type of questions that they're asking. Very simple questions, very simple form of answering, disagree, agree, kind of agree, or just no feeling towards it. And then that was the first test, and I said there was 2. So the next one was the grit scale test. So this one tried to do the same kind of idea as the personality test, except it was looking, instead of the personality traits that I mentioned above, this one's looking for a new personality trait, really, which is the grit, how gritty someone is. And this one had 12 questions. So the other ones, each trait had 10. This one had 12, important to note. And the questions were graded by 1 was very much like me, 2 was mostly like me, 3 was somewhat like me, 4 was not much like me, 5 was not like me at all. And some of the questions include, I have overcome setbacks to conquer an important challenge. New ideas and projects sometimes distract me from previous ones. My interests change year to year. Setbacks don't discourage me. So these are, this is a quarter of the test already. But this is kind of the type of questions that you would expect to get in the grit scale test. And it's important to note that setbacks don't discourage me. If you were to vote 1 here, you would basically have a low grit score, versus if you put a 5, not like me at all, you would have a higher grit score. So that's kind of how the test works. And then, of course, it had the biographical data, the questions on, who are you? Why are you, the person that's taking the test. And we have age, gender, voted, married, family size, religion, orientation, race, hand, English native, gender, urban, education. And so I use some of these later to create a model, a linear model, try to predict. But more on that later, actually. First, I have to also import and clean the data. Of course, as you see above, I already imported it to learn all about it, but the data came in as CSV, and I noticed that some rows were missing, so I got rid of those. It was only 1% of the data, so it wasn't a big deal. But yeah, this is my work with that. And, as I mentioned, I had to do a little bit of work for grading the scales. I wrote a small function to sort the questions in the right category. It was odd were normal, but the evens were negatively based. So you would actually subtract them from the total score. So yeah, so what were my questions? So the questions I had at first was, if grittier people spend more time taking the test, I thought that people who take more time to read the instructions and take more time to read each question would probably be grittier. They'd probably stick with problems longer than someone who just scans, for what to do. And then I decided, could I predict grit from personality tests? because there's so much data on personality tests. In fact, I even found an IPIP psychology test. The official website has around 1 million points, data points on their test. So I was thinking, there's very little people that took grit test. So could I possibly use a personality test to predict grit? That was kind of the main question I came in here to answer. But once I realized that was tough to answer, I actually went and got some more questions, and I started thinking about left-handed and right-handed people who's grittier, and if married people have higher grit. These were just some intuitions. I came in just to try to find out more about grit. So first, I had to explore the data. And during my exploration, I found that there's actually no correlation between the personality test traits. Now, this is important to mention because it means that it was a very good test. It was created in a way to create, statistically significant results. So I applaud the creators of this personality test. They obviously know what they're doing. It's a very popular personality test for a very long period of time. Now, popularity doesn't necessarily mean it's good, but as you can see from this correlation uh, graph, or at least correlation table, none of these correlate with each other at all. In fact, they're all under 0.5, like significantly, and that's the sign of a really good test. So I did the same with grit scale, and actually I found that there was only a couple that were correlated over 0.5, but not really that bad. But one that was over 0.5 that I thought was definitely worth mentioning was number 7 and number 8. Number 7 was I often set a goal but later choose to pursue a different one. And 8 was I have difficulty maintaining my focus on projects that take more than a few months to complete. So I thought that these questions, especially being right after each other, were very similar, and I understand why people would kind of expect to put the same thing, the same answer in each of these. So moving on, I also saw that there was 2 times more females in the study and only 1% selected other, so neither female or male. And I thought that was worth noting. I'll come back to why this is important at the end. But there was also 40% of the participants that were under 20 and 74 were under 30. So this was definitely a study of people who were much, much younger than the general population. This is mainly because it took place in a university setting, and probably the author had a lot of university uh, kids to kind of, forced to take tests, let them know that the test exists versus, the general population. Although there was a ton of people from outside of the US that took the most amount of people that took the test were from the US. So important to note. Again, I'll come back to why all this is important at the conclusion when I talk about my findings. So yeah, so first, as always, as a, learning data scientist, I'm gonna do some hypothesis tests. And I started setting up my hypothesis test specifically for lefty versus righty people. And I actually realized quickly after doing a couple of tests, specifically the D'Agostino's and Pearson's normal test, that my grit scale wasn't really normalized at all. It wasn't normal at all. And I attribute some of that to being cut off at a minimum and maximum value, but it was also a little bit skewed. So I actually had to stop my hypothesis test there because it wasn't normal. And actually I had to bootstrap. So moving on, you can see here that I bootstrapped. So what bootstrap basically means is that I got each different sample. So I divided the groups into lefties and righties, and then I proceeded to use the computer to basically pick a lot of random lefties from the group and create a new sample. Now, I did this with replacement in order to get a lot of values. So I did this with replacement in order to get the same amount of values as I had before for lefties. And I did this 5,000 times. That's the benefit of computers. Later, I also did the same thing with the righties. So I set up my hypothesis. It changed from before, which before we were looking at the mean of lefties being greater than the righties. Because I bootstrapped and I was going to use the difference in means, I had to use a different null hypothesis. And so my null hypothesis was that the mean of lefties was the same as the mean of righties. Again, this is the difference in means. And then my alt hypothesis was actually that the difference in means was not 0. So I actually was able to graph that below, and I actually added the 95% confidence interval because that's how confident I want it to be. And as you can see here, I plotted the difference in grit score means between the lefties and righties. And you can see that 0 is right smack in the middle. It's, one of the most, it looks like it's one of the most common differences in the means. And so this was done 5,000 times, right? So I have 5,000 difference in means. And it looks like because 0 is there, like we just can't confidently say that there's a difference in means. So we actually failed to reject our null hypothesis that there's a difference between the means in the two groups. So lefties and righties, probably not a difference for now, because we're going to continue this test later on and we're going to see what else we can find using different tests. So stay tuned for that. I also did the same thing for married people. Again, same idea. I bootstrapped the non-married and the married group. And I actually found the same result, actually. And the difference in means are here. And you can see that 0, not that centered, but pretty centered in our 95% confidence interval. So I can say that I'm 90% sure that there is no difference in the means of the married and married group in the grit scores. So, you know, we failed to reject the null hypothesis again. So there's no difference in these groups. Cool. So moving on, I decided to move on from my hypothesis tests. That was the easy part. And now getting on to create some models for predicting. Now, the only tool I used for predicting here in this EDA was a simple linear regression. I have other tools to my disposal, but before I did that, I wanted to make sure that I complete this project and see what my initial findings are before I decide to go into more new techniques and updated techniques like k-means or nearest neighbors and nonlinear models, because I wanted this just to be a simple EDA. And you can see that my findings are actually pretty significant. So I'll get more on that. I'll give more info on that later. But for now, let's just talk linear regression. So again, the goal was to predict the grit score using personality traits because there's just so many more personality tests out there than grit tests. And I just wanted to see if it was even a possibility to predict. Now, right here, you can see that this is the formula for our linear model. And yeah, so this is just a little paragraph explaining what I wanted to do. And I graphed the features kind of to see if maybe there was any signal that I can see. Maybe I can see, an upward trend, a negative trend. And the truth is, after looking at these graphs, I really didn't find anything. There's probably going to be no signal. This worried me. This meant that, I was probably not going to have a good model. But I saw here that there was actually a couple of outliers down here that I had missed before. These are actually scores from the total grit score. And this means that there was a couple of people whose grit scores were not well captured, because the lowest you can get is a 12 on the grit score test. So I had to remove those, and I'll talk more about that later. So again, here's the updated formula for linear regression, including my different personality traits. So here we have openness, extroversion, neuroticism, agreeableness, and conscientiousness, plus the noise. And I actually found that down here, we found that openness, neuroticism, and extroversion were statistically significant, which means that they probably have some impact on the model that's significant, on the grit scores in particular. And it was very interesting to see how agreeableness, extroversion, sorry, not agreeableness. Extroversion, neuroticism, and openness all were negatively correlated with grit score. What, like, that's very surprising to me. Probably also means that we have a really bad model. As you can see above on the R squared, our R squared is only 0.076, which means that 7.6% of the variance is explained by this model. And this really doesn't give me any confidence that I can make predictions from this model. So not a good look at all. But again, it doesn't look like this data is linear at all, as you can see above, but it was worth a try. Okay, so let's move on. So yeah, so just simply trying to see if I can fix my model, trying to get the lowest hanging fruit. I went through the assumptions that you would need to do some inferential regression. So basically, simply put, I wanted to see if I could predict anything from this, even though it's a bad model. In order to do that, I had to check 5 assumptions, and some of the assumptions are below. So the first assumption is that if it's linear at all, if the answers are linear, sorry, by answers, I mean Ry, if Ry is linear, and also if there's any outliers. And you do this using a QQ plot. In the QQ plot, as you can see here, we got a pretty good QQ plot, but there was some outliers here. That's what I mentioned before, the invalid grit scores. So I got rid of those, and ta-da, we got a QQ plot that's linear and has no outliers. Perfect. So then we can move on to the second assumptions. So here we're checking for homoscedasticity, and basically you want homoscedasticity, which is that our residuals don't get larger as time goes by. Again, these are kind of the problems that you can get using linear models. This linear model wasn't that good, and it kind of shows how it's definitely not linear. It's a mess. There's no signal here, but funny enough, it does show that they aren't getting worse. So there's nothing that I can really fix here other than using a model. But the variance stays constant. So again, we're not making any mistake here. So moving on, I had to test for multicollinearity, and multicollinearity is actually a very easy test to do with the VIF. And so with the VIF, the variance inflation factor, I noticed that none of the levels were over 10. So I found that pretty good. They were all really low. So it's not like if I removed one of these um, features, I would actually have a better off model. So I was okay with here. Again, no assumption is being stepped on here. Moving on, yeah, so I actually stopped there because I noticed that there was not a lot I could do to improve the model. I did remove the outliers, but that actually had very little impact on my R squared, which is not a good look. So again, another question I had in the beginning, and was my main hypothesis, was that people who took longer to take the test probably got a higher grit score. Again, this is just me and my intuition. I think that people who took more time taking the grit scale test are probably more in tune with their interpersonal self, and they probably spend more time reading the instructions. And so I decided to model that. And this is the formula I used. Grit is equal to some constant plus the feature age. I used time. This is the time taking the test. It's what I'm mainly testing for. And I also added education. So this is less than high school, a bachelor's degree, and a grad school degree, plus some noise, of course. So before I did this, I actually had to clean up the data just a tad more. So as it turns out, I have some test times that were really long, probably people who forgot to actually stop the test and they went to go to the bathroom and they came back, and a long time uh, passed. So I dropped all of those because I was looking for people who were taking the test, they passionately focused and did their best on it. So after getting rid of those, I created some dummy variables for education, and I was able to have different coefficients for each one. And here we go. So an important thing to note here is that 1, 2, 3, and 4 is the different levels of education, with 1 being less than high school, 2 being high school, 3 being graduate degree and 3 being a bachelor's degree and 4 being a graduate degree. And actually, none of them were important or significant at all, except 4 times. So I was kind of right here, super significant, and it got a coefficient of 0.0063, which means that for every second that passes by in the test, your grid scale increases by 0.0063, which you would say, oh my God, that's nothing. That's absolutely nothing. We have grid scores in the 30s. But actually, if you were to multiply that 0.0063 times 60 seconds, you would get a 0.4 increase in grit per minute of taking the grit scale test. So that's definitely something that is important to know. And cool. But the problem here is, again, my model was not good. I got a R squared of 0.014, which is only 1.4% of my variance is explained by this model. So I wasn't happy with this either. Again, this is probably nonlinear data, but I had to do it to see. And I also plotted the residuals. I saw that that was okay. I tested for multicollinearity. Again, age and survey were kind of high, but under 10, so I didn't worry about it. But again, this model does not give me confidence that I could predict grid score from this model. So moving on, this is where things get really interesting, and we talk about Bayes. So Bayes is one of the newest things under my belt, and I've always, knew about Bayes, talked about Bayes, but I have never really felt like I got a good grasp on it, and this really made me understand the power of a Bayesian theory. So I went with the exact same test as before and earlier in the hypothesis test where I bootstrapped, and I tried to see if lefties have a higher grit score than righties. So this time I had to get a beta distribution. Now, in order to do that, I actually decided to bootstrap once again because I had a different theory this time. I realized that I only had 421 lefties and around 3,500 righties, and I wanted to kind of make it a fair fight. So I wanted to increase the amount of lefties that were being looked at. So I decided to bootstrap, and this time, instead of getting the same length of every resample, the same length of the lefties, which would be around 420, I decided to increase the size of the sample, the data points in the sample, to be 5,000. So I did this for the lefties and the righties. So again, because the bootstrap is with replacement, this just means that there's a bunch more lefties that were basically repeated in this larger bootstrap sample that I made. And I did this 1,000 times. So I had 1,000 groups of 5,000 lefties, and the same thing with the righties. I did this to make them equal. I also ended up doing this with the total group, so with the lefties, the righties, and also the ambidextrous group. All 3 were recorded in this survey, so I put them all in one group because I wanted to compare them against something that's kind of like more equal. So I did the same thing as before, where I would compare the means. Now, because this is a beta distribution, things are a little bit different. So I'm going to explain a little bit more in detail everything that I'm talking about. So I got the sample means, the resample means, and I saw that for the mean group, for the total group, it was 30.85. Now, this seemed okay, but then I checked the lefty group and the righty group, and I saw that the lefty and the righty group were much higher than the total group. And I was like, what? How can that be? And then I remembered the ambidextrous people. So I ended up checking the ambidextrous people, and the means for the ambidextrous people are way low. So that was a very interesting finding. Now, I don't know if it's statistically significant, but I know that's what was pulling down the total group means in this bootstrap sample. So I thought that that was a very important thing to note. But I ended up getting the lefty and righty parameters for my beta distribution and ended up graphing it. Now, what this basically graph is, it's the PDF of the distribution created by the parameters. So on the y-axis, we have probability density. And on the x-axis, we have the distribution of the probability success rates. And so here we basically end up having a relative probability of the success rates of lefties and righties that beat out the average mean. So again, we compared this to the total group. So here you can see that there's a huge difference between the righties and the lefties. Now the righties here are on the left and the lefties are in the right. So you can say that the lefties may be in the right. So here we have a 0.77, no, sorry, a 77% or a 0.77 probability that the lefty group has a higher mean than grit score than the total group. So that was very fascinating. Again, it's being pulled upwards by the by not counting the ambidextrous people that had a lower grit score. And so in order to see here, I can see that they're different, but in order to really put, scientific rigor to this Bayesian inference, I had to check to see if there was no funny business going down here in these tails. So I decided to use a quick Monte Carlo simulation. I say quick because, of course, I can do 1,000 Monte Carlo simulations, 10,000 Monte Carlo simulations within seconds using a computer. So I decided to do that. So I drew a large number of random samples from each distribution, and I counted the amount of times that the lefty samples were greater than the righties. And so after doing this, I actually found out that it is 100 times likely that on average that it is this sample of lefties score better than this sample of righties. And again, I say this sample because, as I mentioned right now in the conclusion, there's problems with this study, of course, and there was very little data on lefties. So we would need more data on lefties. But this gives us something to look for. This gives us an intuition so we can ask more questions in the next grit study. So yeah, so moving on to our conclusion and our final findings. So it looks like being lefty might actually affect your grit score, but a more representative sample of the population is necessary. And being married probably doesn't mean you're any grittier, but again, we need a better, more representative sample of the study because this study was a lot of 20-year-old college students that weren't married. So when trying to predict a model using linear regression, R squared was very low and there was no clear signal at all. So we might need more data in order to predict anything useful. Again, what I think is that we probably need a non-linear model. And lastly, people have very complicated histories. We can't simply just use 2 personality tests to predict someone's future. That would be wild. So, it's important to note that people have very complicated backgrounds of all types, and this probably affects grit and personality tests way more than anything we could know. So, it's a complicated subject. And yeah, the caveat is that all these findings are not really representative of the people of all walks of life. And, most of the people were American, college students, educated. There was very few lefties. And so, those are kind of the things that we have to deal with and talk about. But also, an important thing I want to know is that since this was an online survey and people can just answer, people answer the questions themselves, they might ask, you might read a question and ask yourself, hey, am I someone easy to give up? And you might say, yeah, I am. But then, a third party or a friend might look at you and be like, no way, you're someone who's hardworking. So it's important to mention there's a lot of personal bias in these tests. All right, so now moving on to our next steps. So there were some things that I want to continue. Like I really do want to continue seeing if um, this lefty and righty grit score amounts to anything in real life. Now, I did some outside research and included the link right here that, in fact, lefties versus righties in the amount they make in a lifetime, they found out that lefties actually make a very little less than righties, but around 5% less than righties if they don't go to college. But in fact, lefties that go to college end up making a significant amount more, like 10% more. So for all the lefties out there, uh, go to college because you'll be making significantly more. It looks like. Again, this is just according to this one study that they did in the UK and in the US. And so, as I found in my findings, inconclusive but still interesting, lefties might have more grit than righties. Lefties might be grittier. And you can think of why that might be. That might be because, lefties are, in a world that's not made for them. They constantly have to compromise, and they might be more used to having to compromise. And so they might be more used to having to work and persevere when things get difficult. But again, this is this is a very inconclusive thing, although these findings can be used to continue the research. And if I was going to go further, yeah, I would definitely work on my model with linear regression. I would want to combine a large 1 million plus data set of IPIP data, which is the personality test, and predict all those people's grit scores. That would be very cool. If I can get a model that's over 80, 90% accurate, that would be cool. I just don't think that using a linear regression model I can get there, at least not with significantly more data about people's backgrounds. So yeah, so that was the end of my presentation. This is the long one. I think I'm going to also add a short one later on, a little summary. But here's my code if you would like to go through it. It's got 3 different Jupyter notebooks for the 3 different sections. This is my contact information. And I hope you guys enjoyed this video, and see you next time. Peace.